to discuss some the general things in terms of we have to think in terms of Mac perspective. Okay, now there are some blocks are there, so that blocks is commonly called as CCM blocks. Okay, CCM blocks, look at here. CCM blocks will start from B0, B1, B2 to B2 up to Bn. Okay, now the block B0 is a fixed one and block B1 is also fixed one. From here to here, I mean from B2 to Bn, the blocks will have the normal payload. Okay, now we'll see the block B0. If you look at this block B0, totally will have 16 bits. So before that I want to tell one more point. AES is a AES 128, so we have to give 128 bit as a input data, and we have to give 128 bit key, so that we'll get 128 bit encrypted output as a output, encrypted data as a output. Okay, now first we are going to discuss about authentication blocks from B0 to Bn are known as authentication process blocks. Okay, now each block will have the length of 16 octets. Now look at here, first octet will have the flag of 59. Okay, and the next 13 octets will have the value nonce, and at last we'll have the I of M. This also we have discussed in wireless USB. I of M means authenticated message length, MSB and LSB. Okay, this is all about B0, block B0. Now come to block B1. In block B1 we have to have first the length of the authenticated message length, and in the next 10 bytes we'll have MAC header. Okay, then encryption offset and security, this and all reserved byte, and the last byte is also will be set to 0. So this is the format of B1, and if you look at this table here also will have totally 16 octets. Okay, and from B2 to Bn is related to the data. Look at here, first we'll have secure payload position not to be. So in that they have divided into two parts, the payload which is encrypted and payload which is not encrypted. Okay, and for that they named from B2 to BM-1. Similarly, the payload is encrypted, starts from B of M to B of N. And if you look at here, they are using the 0 padding. Why? In order to make each block having the length of 128 bits. Suppose we are having and the payload which is not to be encrypted of 120 bits. So in there 8 bits are shortage, right? So it will do the 0 padding with that, so that it will be rounded as 128. Okay, so this is how they will give it as a input for AES block. So far we have seen authentication blocks, okay, from B0 to Bn. Now the second kind of blocks is encryption blocks. While we do the encryption, how we have to give? Look at here, the encryption blocks will have the blocks like this. First we'll have the first octet is what? Flag. There in authentication block the flag is different, right? 59. Here the flag is 01. Okay, so next we'll have the nonce. We know that nonce is a 13 octets, and then counter value. So for in order to do the encryption, we have to use that AES as a counter mode operation. So these and all defined in that RTL explanation video lecture. Okay, how it will increment the counter and all everything in that RFC 3610 document. Okay, so it has to give this kind of blocks to that AES block. In turn it will get the encrypted format at the output side. Okay, so this is all about this fifth chapter. Okay, so what all things we have seen? First we have discussed about the security mechanisms, what are the security mechanisms we are using here, and then security modes. Then we have discussed the temporal keys, then how replay counter is used here to prevent replay attack, and at last we have seen that AES 128 inputs. Okay, so this is all about